All right, 3 exercises for you on expected value. The first one is, assuming heads equals 1 and tails equals 0, what's the expected value of the toss of a fair coin? And the second question is, what's the expected value of 2 tosses of a fair coin? And then for our third exercise, let's say you are one of 1,000 people to purchase a lottery ticket. The ticket costs $10 and pays out $5,000. What value should you expect from this transaction? I'd also like to note here that there's some funky things going on with escape characters. So you've got to treat dollar signs especially because they mean that you're dealing with formulae in LaTeX. And for whatever reason, in my local Jupyter instance, I had to use double escape characters here in order to render this properly. But for some reason in Colab, you see one of the 2 escape characters. So anyway, it's deliberate, but it doesn't render how I would like it to in Colab. So for our first exercise here, for a single coin toss, the expected value is half because we've got an outcome of tails and a 50% probability. Half the time we're going to have tails and half the time we're going to have heads. So half times 0 is 0 and half times 1 is half. Add those 2 terms up and we're left with half. All right, for exercise 2, we have 2 coin flips. And in a world where getting 2 heads is worth 2, getting 1 heads is worth 1, and getting no heads is worth 0, well, the probability of getting 0 heads is 1 in 4. The probability of getting 1 head is 1 in 2, and the probability of getting 2 heads is 1 in 4. So that gives us our 3 terms. A quarter times 2 is equal to a half. Half times 1 is equal to a half. And anything times 0 is equal to 0. Summing up our 3 terms, half plus 0 is equal to 1. So the expected value of 2 coin flips where heads is worth 1 is 1. And then finally, exercise 3 here, maybe even a little bit of a life lesson. If you're 1 in 1,000 people who purchases a lottery ticket for $10 and the payout on that lottery ticket is $5,000, in that case, you have a 1 in 1,000 chance of winning. And if you win, you'll get the $5,000 minus the $10 that you spent on the ticket. So in that 1 in 1,000, you have a 1 in 1,000 chance of making $4,990 by buying that $10 lottery ticket. However, you have a 999 out of 1,000 chance of just losing your $10. And yeah, so that term is the same here. Simplifying a bit, 1,000 times 4,990 leaves us with $4.99. Meanwhile, in this other term here, 999 over 1,000 times negative $10 gives us negative $9.99. Subtracting 999 from 499, we're left with an expected value of negative $5. So that means that your purchase, this transaction that you engaged in of buying a lottery ticket for $10 has an expected value of losing $5.